Today we're going to start talking about exponents. You probably already have some prior knowledge of exponents from elementary school, but we're going to build on that today. Now, before we actually get to exponents, I want to remind you of some things that you do know from elementary school. You know, for example, that if I have something like 6 times 7, that what that really means is 7 plus 7 plus 7 plus 7 plus 7 plus 7. So it really means to add the 7 6 times. And you probably know that division is really repeated subtraction. So for example, something like 24 divided by 8 really means how many 8s can you subtract from 24. So 24 minus 8 minus 8 minus 8. So multiplication is repeated addition. Division is repeated subtraction. You may not realize it, but there is something for repeated multiplication as well. And that's where we get into exponents. So what we're going to be talking about today is things like 9 times 9 times 9 times 9 times 9. So that's repeated multiplication. And you can write repeated multiplication using exponents. And here's what that looks like. When you use an exponent, the exponent tells how many times the base is written as a factor. The base is the number that's being multiplied, and the exponent is how many times you're going to use it. So in our example, this says 5 to the 4th power is how we would say it. 5 to the 4th power means 5 times 5 times 5 times 5. Or in other words, the 5 is what we're using to multiply, or what we're repeatedly multiplying, and the 4 is how many times we're multiplying it. 1, 2, 3, 4. So 5 multiplied by itself 4 times. It is not the same thing as 5 times 4, because if you think about it, 5 times 4 is 20, but if we actually worked this one out, 5 times 5 is 25, 5 times 5 is 25, and 25 times 25 is 625. That's very, very different than just getting 20. So we have to realize that when we write repeated multiplication, that we're going to get something different than if we're just multiplying two numbers. Now there's some special vocabulary that goes along with this also. When we have something squared, that means it's being raised to the second power. So example, with a base of 4 and an exponent of 2, we could read that as 4 to the second power. Some of you might have read it as 4 to the power of 2 in elementary school, but we could also read it as 4 squared. Cubed means to the third power. So when the exponent is 3, you could say to the third power, to the power of 3, or cubed. What you most often hear as you move along in school is probably going to be cubed. And you also need to know that exponential form is when you write a number with a base and an exponent. So the base and the exponent, that's exponential form. So let's look at some examples. Expanded form is when we write out the repeated multiplication. Exponential form is written with the base and exponent. And product is what we get when we actually multiply it all the way out. So for this one, our first row, we have 2 times 2 times 2. And that's going to equal 2 to the third power, or 2 to the power of 3, because we've used 2 is the number that's being multiplied and 3 is the number of times we're using it as a factor. And if we were to actually work that out, 2 times 2 is 4, and 4 times 2 is 8. So our product here is going to be 8. Our second example here is 2 to the 5th power. So 2 to the 5th power as repeated multiplication means still to use 2 as our base, but this time we're going to use it 5 times, or use 2 as our factor rather, but we're going to use it 5 times. So 2 times 2 times 2 times 2 times 2. And our product then is going to be what we get if we multiply that out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So product is what you get when you actually multiply it out. For our next one, this is a little different, but we can still do this with variables. So when we use a letter in a math problem, we generally call that a variable. So our variable in this case is what's being repeatedly multiplied. So we're going to have A as our base, and We're using it as a factor 1, 2, 3, 4, 5, 6, 7 times. So it's a to the 7th power. We can't actually find the product here because we don't know the value of a. But if I said a is 8, then you would do 8 times 8 times 8 times 8 times 8 times 8 times 8, which would be a pretty big number. So we're not going to do that. Our next one, this is a little different because we don't have the same base the whole time. We do, however, have repeated multiplication. So we have to kind of look at this and say, well, I could chunk this part and I could chunk this part because those are repeats of the same base. 6 times 6 can be written as 6 to the 2nd power, or 6 squared. 8 times 8 times 8 times 8 can be written as 8 to the 4th power. The big question people always have is, what do I put between them? And a lot of people want to put an addition sign, but that's not correct. It's not going to be addition. It's going to be multiplication, because that's the symbol that was between them to begin with. So this one says 6 squared times 8 to the 4th power. And I'm not going to ask you to multiply that all the way out, although I would hope that you could. When you do multiply that all the way out, you get 147,456. And our last example is 2/3 times 2/3 times 2/3. So I want to point out to you that your base does not have to be a whole number. It's okay for it to be a fraction. So in this case, my base is 2/3, and it's going to be raised to the power of 3, or it's going to be cubed. Sometimes you might see parentheses put around a fraction so you don't accidentally think that it means 2 to the 3rd power divided by 3. So you may sometimes see parentheses put around the fraction. If we actually worked this one out, we're going to get 8/27. Now you might be wondering, well, what if your exponent is 1 or 0? Well, any number that has 1 as your exponent, any number to the 1st power, is always going to equal the base. So for example, 5 to the 1st power is 5. 17 to the 1st power is 17. And any number to the 0 power always equals 1. A lot of people mistakenly think that it equals 0. It does not equal 0. Any number to the 0 power equals 1. And I bet you're thinking, how in the world can that be possible that any number to the 0 power is equal to 1? Well, let's think about this for a minute. I'm going to start with the example of 5 to the 4th power. We know that that means 5 times 5 times 5 times 5, which if we worked it out means 625. Now, if we think about it for a minute, if we go down a power, meaning we take our power from 4 to 3, then what we're doing is using 5 as a factor one less time. So let's look at that. 5 to the 3rd power would mean 5 times 5 times 5, which is 125. Notice I could also get that by doing 625 divided by our base of 5. So in other words, 5 to the 4th power divided by 5 equals 5 to the 3rd power. If we continue that pattern, 5 to the 2nd power means 5 times 5, which we know is 25. Notice if we took 5 to the 3rd power, its value is 125, so 5 to the 3rd power divided by our base of 5, we're going to get the value of 25, which is the value of 5 to the 2nd power. Let's keep going. 5 to the 1st power equals 5. And the reason it equals 5 is because if we think about the value of 5 to the 2nd power, when we divide it by our base, which is 5, then we're going to get 5, which is the value of 5 to the 1st power. So in other words, every time you go down a power, what you're really doing is dividing by the base, which should make sense because as you go up a power, you're multiplying by the base again. So now, here's the kicker. Think about 5 to the 0 power. 5 to the 0 power has to equal 1 because it has to equal the value of 5 to the 1st power, which is 5, divided by the base, which is also 5. So 5 divided by 5 is 1. Therefore, 5 to the 0 power is 1. And that would work for any number that you wanted to try it with. So just to review, take a moment and look at this and see if you can write each of these as repeated multiplication. What would they look like as repeated multiplication? You can pause and take a moment to try that, and when you're ready, hit play. All right, if you have done it correctly, here is what you should have as your multiplications. And notice I don't have a multiplication for 8 to the first power because I'm only using 8 as a factor one time. Let's do a little more practice. Let's find the value or evaluate these exponents. So for 5 to the second power, or 5 squared, it's going to mean to use the 5 as a base, or as a factor twice, rather. So it means 5 times 5, which is 25. So the value of 5 to the second power is 25. How about m to the third power, or m cubed, if m is 7? Well, all that really means is wherever the m is, we're going to put a 7. So if m equals 7 means wherever the m is, put a 7. So this really means 7 to the third power, which means 7 times 7 times 7. Well, 7 times 7 is 49, and then we just need to do 49 times 7. 49 times 7. 7 times 9 is 63, so put down the 3, carry the 6. 7 times 4 is 28. 28 plus 6 is 34. So 7 to the third power is 343. And last but not least, 3 to the fourth power would mean 3 times 3 times 3 times 3. And I could work that straight across, or I could also say, well, 3 times 3 is 9, and then use the other two 3s. 3 times 3 here is 9. And I bring down the multiplication because that's what's between those sets. And 9 times 9 is 81. So 3 to the fourth power is 81. So now that you've seen some examples, take a moment and see if you can look at these examples and figure out what the mistake was and even fix it. You can pause while you do that, and then when you're done, hit play and we'll go over it. All right, so 4 to the third power. Our problem is that doesn't actually mean 4 times 3. So here's our problem. That's wrong. 4 to the third power means 4 times 4 times 4, which equals 4 times 4 is 16 times 4. And when we actually multiply that out, 16 times 4 is 64. So 4 to the third power, or 4 cubed, equals 64. And let's look at the next example, 3 to the third power. Well, 3 to the third power does in fact equal 3 times 3 times 3. So this first line is correct. The problem, however, is that 3 times 3 right here, where we first worked this out, this 3 times 3 does not equal 6. So here's our problem. Instead, when we work this out, 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. So 3 to the third power, or 3 cubed, is 27. All right, now to wrap up, I want you to take a few moments and see if you can find the value of each of these numbers that are written in exponential form. So pause while you do that, and when you're done, hit play and see if you've gotten them correct. You may or may not use all of the numbers. All right, take a look and see if you have it correct. And if you have any that you missed, go back and take a look and see if you can figure out why you missed them. Now we've gotten a pretty good overview of exponents, and we should be ready next to start looking at how we can use them in problems.